Hi, my name is Scott Edwards and I'm the Chief Operating Officer here at entX. I'm responsible for the development and commercialisation of our targeted products in entX's space and defence pillar. Our two products closest to commercialisation are our Betavoltaic power generator, what we call GenX, and our lunar night survival technology, the radioisotope heating unit, or what we call RHU. So what is GenX? So GenX seeks to solve a core problem in defence and space systems, and that's the ability to have access persistent and reliable power. So long duration persistent power remains a critical constraint across modern defence capability. This is increasingly evident in autonomous systems which operate in contested and remote environments such as maritime, behind enemy lines, where they need to be independent for extended periods of time without recharge or resupply or recovery. These architectures remain fundamentally constrained by endurance. Batteries perform well, but not over extended periods and not in harsh environments such as extreme cold or extreme heat or under pressure. And solar, while quite useful, remains unreliable, particularly where assets must remain covert or operate in extended dark periods or in subsea environments. As a result, defence agencies are actively exploring Betavoltaics to address this mission-critical capability gap to enable long-life, low-maintenance power for persistent distributed systems such as sensors. Betavoltaics are actually very similar to photovoltaics. Rather than taking light from the sun, it actually takes the energy from radioactive decay. Some call it a nuclear battery, where realistically it's more like a nuclear generator. So when matched with the right radioisotope, GenX can produce power for years, potentially decades, and is suited for extreme environments such as space, the seafloor, ultra-cold conditions, or covert deployments. Betavoltaic's been around for decades, but have always been associated with ultra-low power in the realm of nanowatts. But this power doesn't address those defence capability gaps. To address this gap, Betavoltaic needs to be operating in far higher power regimes to unlock those new applications and new possibilities. GenX does precisely this and is targeting these new applications. So what is the GenX competitive advantage? Why is it different? So GenX is a thin film composite Betavoltaic power platform developed by entX to deliver high power density. GenX at its core is IP that replaces conventional wafer-based designs with ultra-thin stackable inorganic semiconductor cells, which use novel electrode combinations. Wafers, which have been traditionally used in Betavoltaics, are hundreds of microns thick. GenX is only tens of microns thick that can be interconnected. And entX has approached the development of GenX looking through the lens of manufacturing scalability, more of a top-down approach as opposed to a lab scale-up approach. GenX is already compatible with off-the-shelf volume manufacturing processes that you would find in many industries. GenX has been developed in collaboration with our university partners. We've now transitioned that technology into a prototype manufacturing facility in entX's high radiation clean rooms. So we're currently operating within TRL 6, so Technology Readiness Level 6, and undertaking product and process validation. The intent is that this facility will evolve to support low volume production, so we can target the development of mission-ready prototypes for our target customers and get them into the field. In parallel, we've been sourcing radioisotopes. We've been sourcing radioisotopes with half-lives that suit our target applications. Radioisotopes with half-lives that range from months to a few years up to 30 years. So when we look at designing GenX for applications, we don't want to do that in a vacuum. So we're at a point now where we're actively engaging with customers to design GenX for specific applications and their future concepts. The focus is on autonomous battlespace sensing, so unattended ground sensors, undersea surveillance systems, and covert devices. So it's important that as we design these systems, we get feedback from the customers. We don't want to design something that's irrelevant, we want to design something that's ready and mission ready to get into the field and test. We are seeking to get mission ready prototypes into the field this year. In our initial target applications where demand is strong and our power outputs are offering real opportunity, and these sensors are doing just that. Our focus will be on the US, and that's where the opportunity really lies. GenX opens access to multi-million-dollar procurement pathways across defence, intelligence, aerospace and space.